Hello, today we are going to be continuing our work from yesterday on polynomial approximations for different functions that aren't necessarily polynomials. So here's what I've got from yesterday's homework. You should have figured out that sine of x can be approximated by the polynomial x minus x cubed over 3 factorial plus x to the fifth over 5 factorial. And then same thing with cosine. Cosine can be approximated by 1 minus x squared over 2 factorial, x to the fourth over 4 factorial, x to the sixth over 6 factorial, so on and so forth. Now, a few things that are interesting about this. First off, think about sine of x. Sine of x is an odd function, meaning that it has rotational symmetry about the origin. This should come to no surprise to you guys that, hey, an odd function seems to be the sum of a bunch of odd degree polynomials. This next one would be x to the seventh all over 7 factorial, and so on and so forth. Same thing with cosine of x. Cosine of x is a nice, beautiful even function. So since this is an even function, it should come to no surprise to you that it is approximated by even degreed terms. So that is some pretty beauty involved in this math. Kind of a review of some of our Algebra 2 concepts. But that is the way that I typically remember those. Sine of x is an odd function. It is the alternating sum of odd terms. Same thing with cosine. Cosine is even, so it is an alternating sum of your even terms. All right, now, one thing that we did yesterday and I mentioned is that all of these have been centered about 0. What if I'm not interested in 0? Sorry, 0. But what if I were interested in centering this around something else? What if I wanted this approximation to be centered about 2 pi or centered about 4 pi? Or maybe I don't even want it to be shaped like this. Maybe I want it to be centered about 5 pi over 6. I don't know why anyone would want that, but what if we wanted to center this around a different number? Well, we are going to learn how to do that today. And guess what, guys? It is the exact same process. So here's what I would like to do. What I would like for us to do today is to find a sixth order polynomial approximation for sine of x centered at x equals pi over 2. Now, a few of you sharp ones might be thinking, wait a second, this lady just told us that sine is going to be a sum of odd terms, and she's asking us for the sixth order, the sixth degree polynomial. Why would we need a sixth degree? Well, guys, I should have been more specific on my previous slide. Sine is a sum of all of our odd terms when we are centered about the origin, and cosine is a sum of all of our even ones when we're centered about the origin. We're not centered about the origin anymore. We're centered about pi over 2. So here's what I would like for you guys to do. Same process. We have f of x is sine of x. You're going to need to find the first derivative, the second derivative, the third derivative, fourth, so on and so forth. You're going to need to find these. And what I would like for you guys to do is evaluate those at pi over 2. And then go ahead and stop there. If you want to take a moment and try to write out what that polynomial would look like, you may, but I just want you to take a moment to figure out those derivatives and figure out what are those evaluated at pi over 2. So please, please, please take a moment, pause your video, and I would like for you guys to go all the way out to that sixth derivative and then evaluate those at pi over 2. All right, I hope you took some time to go over that one. Let's go ahead and look at our different derivatives here. So here's what I got for my derivatives and their evaluations at pi over 2. So looking at this, looks like I've got a constant. I'll have an x squared term, an x to the fourth term, and an x to the sixth term. And I know that might seem strange right now since we're dealing with sine, but I promise you it's not going to be strange here in a few minutes. So, few considerations that we need to make now that we are centered at something else. So first off, let's get started. Our constant term is 1. I will not have a linear term in this one because I have a derivative of 0 there, so don't worry about that term. My next derivative is -1, so I'm going to have negative. Now, I know it would be really tempting to write negative x squared. However, we are centered at pi over 2. So this will be the quantity x minus pi over 2 squared, and then don't forget over 2 factorial. All right, our next non-zero term is not going to happen until our corked term. So looking at this, this is going to be a positive. And then same thing, we are centered at pi over 2. So pi over 2, this will be to the fourth divided by 4 factorial. And then finally, our last term is going to be that 6th degree one. And then finally, that would be minus the quantity x minus pi over 2 to the 6th power divided by 6 factorial. All right, now I want to talk about why this is not very surprising that we have these terms as our even powers. Let's go ahead and go back to the graph here. All right, so I wanted sine of x, an approximation for sine of x, but I want it centered about pi over 2. Guys, if I'm centered about pi over 2, my first one's going to look like this, and then it's going to look like this. And guys, that really just looks like a cosine that has just been shifted. This, think about it, is just a cosine of x that has been shifted pi over 2. So with that term, let's look at how we adjusted that series. This is x minus pi over 2 squared. Oops, not you. Squared. And we just shifted all of these terms by pi over 2 to the right. You might think it's a waste of time that I'm writing this, but it's just satisfying. Sorry. All right. So these are the exact same things. We simply just shifted it over and we centered it about something else. Now, I want to go ahead and talk about vocab terms here. All right. And I hope that you enjoyed this. I laughed the other day when I found this. We are talking about two different types of series, Taylor series and Maclaurin series. Taylor series are where we have the derivative evaluated at n over n or derivative evaluated at a over n factorial, and we're centered about a. That is a Taylor series. Now, no need to thank me, Maclaurin series. That is just a special Taylor series that's centered at 0. No need to thank me. So if you see something that is talking about a Taylor series, you're going to be centering it about something other than 0. If it's asking for a Maclaurin series, you're centering at 0. Yet again, no need to thank me. And if you want a picture of these two fellas, this is Taylor, and this is, I believe it's Brooke Taylor. And oh goodness, what's Maclaurin's first name? Okay, I'll have to look it up. Maclaurin. What is Maclaurin's first name? Colin Maclaurin. Look at him. All right. So Taylor series, something other than 0. Maclaurin series at 0. All right, so here are your problems for today. First off, there is that Khan Academy assignment that I assigned yesterday over Taylor series and Maclaurin series. And then I also have 2 other problems that I would like for you guys to look at for tomorrow. You do not need to email these to me. Please don't. I hope that this will be kind of an aha moment for you as you're working through these problems. So here are the 2 problems that I would like for you guys to at least think about after you're done with your Khan Academies. I would like for you to find the 5th order Maclaurin series for e to the x. And I would also like for you to find the 5th order Maclaurin series for 1 over 1 minus x. So you might have a little bit of an aha moment as you're doing these, but please look at these for Friday. That is where we are going to start a lesson. All right, I hope you guys have a wonderful day. Please let me know if you have any questions, and I will talk to you tomorrow.